This section covers the sample management system, and there are two major components to that. That is the sample carrier and the injector system. Now, the sample carrier consists of this mechanism. There's a line drawing, and there is a three-dimensional CAD/CAM drawing showing the assembly. The numbers indicate different parts. Number 1 is a stepping motor, and that's the carrier motor. The carrier is this part that actually holds the carousels and moves one carousel at a time around so that injections can be made from the different carousels. Inside, there is a device called an indexing wheel on it. It has 5 positions, 1 for each of the carousels. And there's also a position marked for the home. One of those positions is the home position. The home position on this machine is the A carousel will be right behind the door to the sample compartment. So when you turn the machine on and it initializes, when you open up the sample door, the A carousel, or the position for the A carousel, is right in front of the door. That's what's called the home position of the machine. Motor number 2 is the carousel motor. That rotates the carousel around. It has an indexing wheel as well. The indexing wheel here has 24 positions, 1 for each of the vial positions on the carousel. It also has a home position for the carousel. The home position on the carousel is the lowest number on the carousel. So for carousel A, that's position number 1. It's position number 25 for carousel B, position number 49 for carousel C, and so on. There are also a couple of other sensors on this. The one over on the right is called the vertical home position sensor. This tells the machine that the mechanism that turns the carousel is raised up all the way, and it's now safe for the for the machine to rotate to a new carousel. This one on the CAD/CAM drawing marked number 5 here is a little fence, and this goes into a sensor when the arm is all the way down. Now it's kind of hard to see, but on this drawing there's a little yellow button. That little yellow button is actually a pin. Now, the pin sticks out from the arm. It goes into a keyhole on the top of the carousel. That's what allows it to turn the carousel. So when the arm comes down, that arm comes down into the hole in the center of the carousel, and then it rotates until the pin drops into the keyway. Once it drops into the keyway, it's sensed by this sensor, marked number 5, and now the machine knows it has engaged the carousel and it can begin looking for the proper carousel. Now on the top of the carousel, there are 6 fingers, and one of those fingers on each carousel, it's a different finger, has a hole in it, and you usually see a little metal piece inside that. That little round metal piece is actually a magnet. The machine knows where that little pin that sticks out from the arm is pointing. And so when it picks up that magnet, it knows the angle between the pin and the magnet, and therefore it knows which carousel it has picked up. If you accidentally put the B carousel where the A carousel should be, and you tell it to go start making injections off the A carousel, what will happen is the machine will give you an error message. It will tell you that the wrong carousel is in position. This is how it's able to do that. That's important because you've told in a program, you've told the machine that sample number 1, position number 1 is a standard, and position number 5 is sample ABC. Well, if you have the wrong carousel inside there, you more than likely don't have standards, and your samples will be misidentified. So that's why that function is there for you. The machine will actually stop making injections if you have an error that the wrong carousel is in position. This next slide shows the 2695 injector. Now, this is the first available injector, the original injector. On the top, there's a stepping motor. It turns a lead screw. The lead screw turns a slide that moves up and down. That slide moves the needle up and down through a device we call a seal pack that is a set of seals that can hold high pressure. And then the sample, once injected, will go out a tube to the column. This is what's called the Phase 2 injector. It's a newer style injector. It has a new seal pack on it. Uses the same seals, same rebuild kit, same PM kit. This injector has fewer parts to it. Fewer parts mean fewer tolerances, which mean we can get the injector to perform more precisely. Here's a cross-section of the seal pack, and this is kind of a schematic of the entire, both the classic seal pack and the phase 2 seal pack. The needle, in this case it shows the needle down below the seal pack. The needle port, you might notice, is on the side of the needle. It's not at the tip. That's why we have 2 seals inside the injector. The port being inside those 2 seals is what's called the stream position for the injector. That is, the port is in the flow stream from the pump to the column. On the top, we have a needle wash in, and on the bottom, a needle wash out. The needle wash will wash the outside of the needle. We wash the upper part of the needle because it's been sitting in the air, and there might be dust, dirt, chemical vapors on it and such, so we want to remove those so they don't interfere with the separation. The lower part of the needle has gone into a vial. We want to wash that off so that we prevent carryover from one sample to the next. Inside the injector as well, the injection system, there are 2 HPMV, which stands for high pressure motorized valves. The motorized valves are what are called a 3-port 2-way valve. Flow can always go through this way, across. Coming out the front part of the valve here, when the valve is closed, a port, and this tube is hollow from the port to the tip of the tube, is outside the flow stream. So flow can only go directly through the valve. When the valve is open, this device, which is called a spool because it looks like a spool of thread, gets pulled back, and now the port is between the 2 seals and flow can come out this opening. We direct the flow by putting a restriction on one side on the outlet side of the valve. These valves, essentially we do not stop the flow at all going through the system. We direct the flow using restriction. Flow will always follow the least path of resistance. Here's a schematic of the injector system. Now, this injector system, it's nice, but it's static. And there are pictures, a series of pictures, but they only show, again, static functions. And there are words in the book, but between each picture in the book, 3-4 steps have taken place sometimes. So there is an injection sequence, and there's this little video. I'm going to start off showing the purge sequence on the Alliance auto injector. Now, these are what we call the normal positions for the valve. Valve 1, which is also called the inject valve, is open. Valve 2 is closed. Valves 3 and 4 are closed. 3 is the waste or vent valve. 4 is the needle wash valve. Flow comes from the pump, goes into valve 1, and because there is a restriction on the outlet of the valve, flow is forced up through valve 2, which is closed. 95% of the flow goes this way. It goes through a 3rd transducer on this instrument, which is called the sample transducer. It measures the pressure inside this sample loop. Goes down through the sample loop, out the port on the needle, and off to the column. Meanwhile, 5% of the flow goes through the restrictor, around the needle, and off to the column. When you first tell the machine to do a purge, the first thing that happens, it stops the flow. This is so when we change the valve's position, there is no sudden drop in pressure. It then will close valve 1, open valve 3, and open valve 2. It then begins pumping at 3 milliliters per minute. This is programmed into the machine. If you've done a purge from the front panel, it will ask you how many sample loops you want to purge. And it will calculate, based on what the sample loop is, the time to flow through. If you're purging from Empower, though, in Empower you set a time. So if you say 2 minutes, the valves will remain in this position for 2 minutes. It does the first part of the purge. When that's finished, it does the second part. During the second part of the purge, several things occur. First, valve 1 opens. Secondly, the syringe empties, fills, empties, and comes back to the home position to change the solvent out of that syringe. Also, the flow slows down between valves 1 and valve 2. The flow from the pump slows down to 0.45 milliliters per minute. That's to save solvent, because this entire cycle of flushing out the syringe takes approximately 2 minutes. It always does those first 2 points. If you've elected to take a compression test, the needle, the port in the needle, is placed into the lower seal. Valve 1 will close. Valve 3 closes. Now the sample loop is isolated from the system, but it's still connected to the syringe. The machine will run and determine if there's enough back pressure to properly run the test, and it requires about 500 psi to do this test. It will then drive the syringe up to the pressure limit, stop, and wait for the decay. Here it is, the pressure is dropping down, and the final pressure of 80 psi, well, 78 psi. It passes the test. When it's done, the machine returns to its initial state. Now that we've seen how this is done, let me show you how to interpret the results. I'm going to plot the pressure, and I'll put it in psi, versus time. As the machine begins compressing the liquid inside the syringe and inside the sample loop, the pressure rises up. Because it's hydraulic pressure, it tends to rise very quickly. The pressure goes up to a point where we've set the pressure limit, so I'll mark that as PL. The pressure falls off very rapidly at the beginning. This is not a leak. This is what we call, I'll put a C, for compliance. System compliance is all the curved tubing inside that machine is now trying to straighten out to relieve the pressure. It then goes into some sort of steady state decay. After it reaches the pressure limit and the machine allows for the compliance time, it takes a reading, P1. A little while later, it takes a reading, P2. It subtracts P2 from P1 and calculates a leak rate. This is what we expect to see from a good system. Now, we could have an air bubble in the system. If we have a large air bubble, we're not going to see any pressure change at all. But if the air bubble is only 2 or 3 microliters, what will happen is we start running and the pressure starts rising, but very, very slowly until the last air bubble is completely collapsed. And then the pressure shoots up, because it's all hydraulic now, and we go into the same sort of thing. So we have a similar shape to a good one, but it's shifted over a little bit to the right. So this would be if we had air in the system. Another thing that could happen is we could have a leak. Again, a large leak, we're not going to see any change in the pressure. But if there's a small leak, like the syringe really isn't tight enough, or maybe a fitting inside the machine on the sample loop isn't quite tight enough. As the pressure will rise up in the beginning, as you go higher and higher in pressure, the apparent leak looks worse and worse, until if it does hit the pressure limit, the pressure drops off very quickly. So this would be a leak. One other thing that can occur. Valve number 3 is a solenoid valve. It's designed to open up at about 400 psi. But if the valve is damaged and it opens up earlier, the pressure will rise up to a point, and then all of a sudden, the valve starts opening and closing, and the pressure never gets any higher. So this is valve 3 is questionable. Now, from personal experience, I've had a machine that did this. The valve opened up at about 40 psi, and yet it would still give me good results. I still got very good reproducibility, better than 1/10 of 1% on area counts and such, because when this machine is drawing the sample, this system is under a vacuum. It's not under pressure. When we do the compression test, it's under pressure. And under pressure, we can't have a leak in one direction. We do that on a pump purposely. We put a device called a check valve in, which allows flow in one direction and not in the other. But effectively, flow is a leak. So this machine is still useful, but it might be on the way of failing. But you can still get good work out of a machine that's doing this. Now, let's take a look at the injection sequence. The injection sequence on this is called the normal sequence. Again, the valves start off in the normal position. Valve 1 open, valves 2, 3, and 4 closed. Flow going through the system, 95% going through the sample loop, 5% going through the restrictor. When the machine is told to make an injection, first step, valve 1 closes. Next step, the port in the needle is lowered into the seal. Now the sample loop is isolated from the system, but it's still at system pressure. Since we're going to draw a sample at ambient pressure, we need to vent the pressure out of the sample loop. So valve 3 opens, and when valve 2 opens, the pressure inside the sample loop vents to waste. Then valve 3 closes. Next, the needle wash pump starts, and valve 4 opens. The needle wash valve bleeds air into the system, so what goes around the needle is not a solid stream of liquid, but it's a froth. The bubbles provide mechanical agitation to help clean off the outside of the needle. The needle is lowered into the vial, and valve 4 will close, but the needle wash pump will still continue for a few seconds. That way, the air that bleeds into the system will flush out and remove most of the needle wash solvent in the system. The frits at the bottom of the seal pack are porous. If the pump stopped and the valve closed at the same time, the solvent inside there could run down the needle and potentially dilute or contaminate your sample. So that's why the pump runs for a few seconds longer. Next, the syringe pulls down, and it draws your sample up into the needle and the sample loop. Note that it fills the needle and sample loop in the opposite direction of the normal flow path. It draws the sample, the needle is brought up, and the port stops inside the lower seal. Next, valve 3 opens, and valve 2 closes. The syringe then returns to the home position. Notice your sample has not gotten into the syringe. All that's in the syringe is mobile phase. Then valve 3 closes. While it is doing that, it brings the port in the needle up into the flow stream, and within 1 second of the port coming into the flow stream, valve 1 opens. Now the flow is directed, 95% of the flow is directed through the sample loop. Your sample is pushed out onto the column. Valve 1 opening is the signal to the machine, that's the injection start. And that's why that valve is called the inject valve. Right now, everything is back in the normal position and ready to make the next injection. That's the injection sequence. That concludes the theory portion of the course. Now we'll go on to the actual hands-on or the actual operations portion of the course, dealing with the configuration of the system.